Experimental probability is when you calculate probability based upon experimental results. To do this, first step, design your experiment. Decide if you're going to flip a coin, roll a die, pull marbles out of a bag, whatever your experiment is. Step 2, set up a table with all the outcomes and tally your data. That means put a mark in each row when that result pops up. At the end of your experiment, you'll count up those tallies to help you do step 3, which is divide the number of desired outcomes by the total number of trials, which means total number of trials is how many times you did your experiment. Let's do a probability experiment. We're going to roll some dice, here's my dice, and determine how often we see an even number. I'm going to choose the 20-sided one, but you could pick any of them, including a regular old 6-sided die, like we call a number cube sometimes in class. And the first thing you want to do is maybe make a prediction. This die has all the numbers between 1 and 20 on there, so I predict that about half the time I'll see an even number, because half of the numbers on this die are even and half of them are odd. Then we do our experiment. We set up a table to tally our data with evens and odds. And then we roll the die. I'm going to roll it 10 times. First is a 20. All right. That's an even number. Remember, even numbers end in 0, 2, 4, 6, or 8. Next is a 17. That's an odd number. Odd numbers end in 1, 3, 5, 7, or 9. A 19, another odd number. A 10, an even number. Another 19. A 5. Ooh. And 11. Another 19. And one more roll. Another 19. We've rolled the die 1, 2, 3, 4, 5, 6, 7, 8, 9. One more time. Another odd number, a 3. So now we've rolled the die 10 times, and then we want to count up our data. So I rolled 2 even and 5, 6, 7, 8 odd numbers. To calculate the probability, we're going to take the number of even rolls and divide by the total number of rolls we did. That's our total number of trials. So we had 2 even numbers out of 10 total. If you use a calculator or do division, that gives you 2/10, which is equal to 20%. So you see my experimental probability, which is based on an experiment, was very different from my prediction, which was 50%. And sometimes in an experiment that can happen.